Welcome back, everyone. I hope you're having a wonderful day. Let's continue on in Excel, and now we want to talk a little bit about graphing, plotting points on Excel. And so what we've got here is some rules that one of the books that I use calls proper plots, the rules for proper plots. And so a couple of things. First off, we label both axes clearly, right? We're going to scale the axes so that they're easy to read. We're going to use grid lines. We're going to use data points if we have data. We're not going to put a line in there unless it's a lot of data. We'll talk about that later. And then we're going to title the graph. So here's just an example of a not very well done graph, right? So this is maybe not a proper plot. So we'll start off by labeling the axes clearly. T and D, since we've been working with the free fall object, that's pretty clear to you what that is. But if you were new coming into this project, you might not know what those stand for. And so we'll go ahead and label this time. And I'll even use the same rules that I used when I was creating the column headers, right? We'll give it a word, and then we'll give it a label, and then we'll give it units in square brackets, right? And then same thing over here, I could say distance, and I'm going to go ahead and I'm going to write up. You don't have to, but that's what I'm going to do here, at least as well as I can as I'm writing. So I'm calling this D, and actually I think I called it Y. And the units were centimeters. Okay, and then we label the axes. That's labeling the axes. Let me jump down to title. I might want to put a title on this. So I might say position versus time. For a free fall object. I mean, if I say position versus time, that's still not descriptive enough. You know, that could be a bird flying, that could be a car going down the road. I don't know what that is. And so I say for a freely falling object or for a free fall object. Don't make it too long, but give something in there. And it might be more appropriate for something like this to be in, let's say you imported this into a Word document. You might have position versus time on the graph itself, but when you subtitle or put a label underneath the graph in the Word document, then you might give it a little bit more detail. That would work out as well. Okay, scale the axes so they're easy to read. So I've done a really bad job of this, right? 7, 14, and 21 seconds, that doesn't make much sense. So you want to use increments that are a little bit more reasonable. So maybe 5, 10, and 15 seconds. And then same thing up here. I might go 100, 200, 300 centimeters, something like that. Of course, we didn't actually go that far, so let's actually change this again. Just looking at the data that I had, maybe it would be more appropriate to say 25, 50, and 75 centimeters. And over here, let me actually change this. No, that stays T, but the seconds, let's make this 1/60th of a second, right? I'm not going to write 5/60ths and 10/60ths and 15/60ths. That's not easy to read. But for me to say in 60ths of a second, then that's a little bit more sensible. And then finally, you'll see what I got here is a dot to dot. Dot to dots are great when you're 5 years old. They're not so good now. So this should just be data points. So let's get rid of the lines that are connecting because they really don't mean anything. I just want to see the data. That's the data that I collected. These are all real points. Now we'll look at a graph later on when I get onto Excel, and it's going to have so many data points that if I do dots, it just becomes this smudge. It's basically a curve, but it's a fat curve, and so it doesn't really do us any good. So in that scenario, when you've got lots and lots of data points, the dots are not reasonable. The symbols, the shapes, and the colors, those need to be varied if I've got more than one set of data up on the same graph. So if I had, let's say, 5 different free fall objects, right, or say different balls rolling down a hill, and I wanted to graph all of those, let's say there's 3 different balls, small one, medium one, large one. They're rolling down the hill. What's their position versus time? I might, in that scenario, use different shapes or different colors to separate the different balls that are rolling down the hill. So that kind of an idea keeps the data separated, and that's a big deal, right? We want that data to be easy to read and easy to discern from one set of data to another, especially if there's crossing going on. All right, so this is a brief idea of proper plots. All right, let's take a look at how we do this in Excel. All right, let's continue on creating a proper plot. And we're going to do a proper plot of time and position here using the data that you see. So what I'm going to do is I'm going to highlight the time and position columns. So I click on A2, I click and hold it down, and then I drag the mouse down to the bottom there. And then I'm going to go up to Insert, and you can see charts here in the middle, and one of those is a scatter chart. And then here there's a variety of them, and you can kind of preview it, right? But we just want the data dots. So there it is. And you can see by default it puts the top of the second column up here in the title. I can make a change in that. I can write up in here, I can say position versus time. And I want to capitalize time. And then down here I'm going to say for a freely falling object. Okay, now a couple of things. You can see this nice curvature of the data. It's not a straight line, it is a curve. Notice this guy right here, that seems a little bit odd. And so one of the things we want to do when we're looking at data and anytime we're doing problem solving is we want to take a look and see if everything makes sense. And this seems a little bit out of place. And so what I actually did is I went back and I remeasured on the long piece of tape where the dots were, and I got to this point right here and I realized that's not 59.7, that's 55.7. So I made a correction there. And you can see how nicely that falls into place. All right, so we want to label the axes. Remember, that's part of it. We want to label the axes. You can see the grids are in already. I've got 5, 10, 15. Those are reasonable. Those are reasonable scales. The grids are here. I've got 10, 20, 30, 40. I can change that if I want. Sometimes what I want to do is I want to elongate the graph because I feel like those were too tight in the beginning there. Okay, so I want to label the axes. So I'm going to click down here in the axes. You see chart tools and design format are highlighted. I'm going to go to design, add a chart element, and I'm going to go with an axis title. I'm going to go with the primary horizontal first. And then in here, I'm just going to say time t 1/60th of a second. In a similar fashion, I can go to, let me click outside of here first. I can go to design, add a chart element, axis title, and now I'm going to do the primary vertical position, and that's Y and centimeters. And so there are the titles on the graph. More precisely, there are the labels on the axes of the graph, and then the titles up at the top. I think I've got a pretty good plot there. All right, if you have any questions on that, please let me know in the comments below. Thank you.